A rule of logarithms that involves products. It says that if you take the log of a product, it's equal to the log of the first plus the log of the second. You have to get it straight. It's the log of the product of two things, is the log base 10 of x plus the log base 10 of y. That's for x greater than 0 and y greater than 0. And it comes and is intimately related to this rule for exponents. 10 to the a times 10 to the b is 10 to the a plus b. So in this case, you add exponents. If you're not familiar with this rule, try a simple example and review. Say take a equals 2 and b equals 3. Okay, so if you believe this rule, we can show that this rule is true. Let's see how. Let's show that log base 10 of x times y is log base 10 of x plus log base 10 of y. So let's start with log base 10 of x times y, and we'll go through a whole sequence of steps, and we'll end up with log base 10 of x plus log base 10 of y. To change log base 10 of x times y into log base 10 of x plus log base 10 of y, we have to figure out how to use this rule. To do it, what I'm going to do is I'm going to replace the x and y by an expression that's equal to x and y. In for x, I'm going to put in 10 to the log base 10 of x, and in for y, I'm going to put 10 to the log base 10 of y. So let's take a minute and study how this expression works out. That log base 10 is that log base 10. That x matches up with this 10 to the log base 10 of x. That y matches up with this 10 to the log base 10 of y. Maybe it's easier to see backwards. 10 to the log base 10 of x, if you were just asked to simplify that, well, you would say 10 to the log base 10 of x is just x, because 10 and log base 10 undo each other. So 10 to the log base 10 of x would simplify down to x. 10 to the log base 10 of y would simplify down to y. So if you were to start with this expression, you would simplify it back to this expression. That is, this 10 to the log base 10 of x is equal to x. This 10 to the log base 10 of y is equal to y. So we can rewrite log base 10 of x times y into log base 10 of 10 to the log base 10 of x times 10 to the log base 10 of y. And you might ask, why would you want to do that? Well, the reason I want to do that is because 10 to the log base 10 of x times 10 to the log base 10 of y, I can now apply this expression. It's 10 to the something times 10 to the something else, and that means that I can add exponents. So this is 10 to the a times 10 to the b. A is log base 10 of x, b is log base 10 of y. So I can rewrite this. That log base 10 is this log base 10. I'm going to take what's inside here and rewrite that as 10 to the sum of these two things. So it's going to be 10 to the log base 10x plus log base 10y. So it's log base 10 of 10 to the log base 10x plus log base 10y. Now look at what happened. I've got log base 10 of 10 to the something, but log base 10 of 10 to the anything is just that anything. So that log base 10 and 10 to that power, the 10 and the log base 10 undo each other. Log base 10 of 10 to the something undoes each other, and we're just left with that exponent, log base 10 of x plus log base 10 of y. So I can simplify this because log base 10 undoes 10 to the exponent. And look at what the whole expression does. I started with log base 10 of x times y. I ended up with log base 10 of x plus log base 10 of y. So this says log base 10 of x times y is equal to log base 10 of x plus log base 10 of y. That's what I was trying to show. This rule gives rise to this rule. All right, let's look at an example of how we can use this. So let's take log base 10 of 50 plus log base 10 of 2. Well, that looks like something on this side of the expression. Log base 10 of 50 plus log base 10 of 2. I don't know what log base 10 of 50 is. I don't know what log base 10 of 2 is. But this rule of logarithms says I can combine the two and write that as log base 10 of 50 times 2. That is, I'm using this rule backwards. Log base 10 of something plus log base 10 of something else. I combine. And log base 10 of 50 times 2 is log base 10 of 100. And I can write 100 as 10 squared. So to evaluate log base 10 of 100, I evaluate log base 10 of 10 squared. Log base 10 of 10 to the anything is just that anything, so I just get back 2. That's a pretty cool way of using this rule to figure out an expression where you don't know the individual pieces. It all just simplifies to 2. Let's look at another slightly harder example where we want to estimate something. We want to estimate log base 10 of 5,000. I don't know quite what that is, but I can estimate it using this rule. It's log base 10 of 1,000 times 5, which I can write using this rule in the forward direction of log base 10 of 1,000 plus log base 10 of 5. And I can simplify the log base 10 of 1,000. Log base 10 of 1,000 is log base 10 of 10 cubed. log base 10 of 10 cubed. Again, we're just left with the 3. So this is 3 plus log base 10 of 5. So I still don't know what log base 10 of 5,000 is, but I know it's 3 plus some number. And this number, log base 10 of 5, I know from the previous video, is always going to be between 0 and 1. Log base 10 of some number between 1 and 10 is always going to end up to be something between 0 and 1. So this is going to be like 3 plus something between 0 and 1. It could be as 3 plus a little bit or 3 plus a lot. It can't be any smaller. This thing can't be any smaller than 0, any bigger than 1. So that means that this 3 plus something is going to have to be bigger than 3 and less than 4. That is, log base 10 of 5,000 is between 3 and 4. So that's a few different ways you can use this very nice rule of logarithms. It has a lot of applications, and it's a very powerful rule.